Let us consider this figure. An object is thrown up with an initial speed u. It is expected that when the object gets to a maximum point, it stops momentarily, which means for the upward motion, the final speed is 0, and then it starts falling back to the ground. In physics, it has been proven that the time it takes for the object to rise to the top and fall back to the ground is twice the time it takes it to rise from the bottom to the top. It means the time taken for the entire flight is equal to twice the time it takes the object to get to the maximum height. So in this video, we want to show that for an object thrown up, the total time for the upward and downward motion equals twice the time to reach the maximum height. So we want to prove that that theory in this video using simple calculation. So first, let's say the time to reach the maximum height, let it be t, lowercase letter t, and let the time of flight, that is the time for it to leave the ground to the top and back to the ground, we call it time of flight, let it be uppercase letter t. What we are just trying to prove in this video is to show that t, uppercase letter t, is equals to 2 times lowercase letter t. So we want to prove that t equals 2t. Now, let's look at the upward motion of the object. As the object is thrown up, it gets to a maximum height where the velocity is equal to 0. So if we recall the equation of motion that says v equals u minus gt. G, because we are looking at acceleration under motion under gravity. So we are looking at g, acceleration due to gravity. The negative is because of the upward motion, and an upward motion acts against gravity. That is why we have it as negative. If we put in values, or rather we are trying to find t, the time to get to the maximum height, right? So let's make t subject of formula. To do that, we are going to have v minus u, if this crosses over, becomes negative u, equals negative gt. To obtain t, we have to divide both sides by g, or divide both sides by negative g, right? So we have that t equals v minus u all over negative g. But note that at the maximum height, which is the time for which we are looking at the time it gets to that maximum height, the v is 0. So if we put 0 in the place of this v, we have that t equals 0 minus u all over minus g. And that is equal to negative u all over negative g. The negative we cancel out, and it means the time it takes to get to the maximum height, t, equals u all over g. Now that we've obtained that lowercase letter t, which is the time to get to the maximum height, let us now go further to find the time of flight, uppercase letter t, and check if it is going to be 2 times this value here. To do that, let us consider the total movement of the object from the bottom to the ground, looking at the maximum height the object attained. According to the equation of motion, the height the object attained, h, equals ut minus half gt squared. Again, g is acceleration due to gravity because we are considering motion under gravity, negative because the object is thrown up, and h is representing distance, in this case height, h. Now we are going to find t. We want to make t subject of the formula. But something I want to bring to our notice is that the height of the object h after the motion is completed. What will be the height? An object was thrown from the ground, it rises up and returns to the ground. It means after the entire motion, after the entire time of flight, the object is back to the ground again. It means the height from the ground is 0. So we can say 0 equals ut minus half gt squared. Now we can make this subject of formula. T is common to both sides of this right hand side of the equation, so we can factorize it out. 0 will be equals to t into this, you'll be left with u minus half gt. One of the t will cancel out one of the t, so we'll be left with just 1t. What it means is that this is a quadratic equation basically, and what it means is that either t is equal to 0 for this equation to be balanced, or u minus half gt squared equals to 0. So we can say either t equal to 0, I'll come back to this shortly, or u minus half gt squared, sorry, u minus half gt equals 0. When t is equal to 0, it is talking about the time at the beginning of the motion. It's looking at the time when you just threw the ball. At that time, we've not started counting, so the time is 0 because you've just thrown the ball. So the time we'll be looking at for eventually is from this other equation, because we are looking at the time it takes to return back and not the time at the point where the object was just thrown. So t equal to 0 is not what we are after in this equation. So let's come back to this. To obtain t, we can take this to the other side of the equation so that you have u equals half gt. Let's go to the next page. So I've brought this back, what we derived earlier, the time to reach the maximum height, c equals to u all over g. And we have also just derived that u equals to half gt. So to make t solve the formula, we can cross multiply. 2 times u equals gt. So we have gt equals 2u. When 2 multiplies u, you have 2u. To obtain t, we divide both sides by g. So that t, sorry for the repetition, so that t will become 2u all over g. T equals to 2u all over g. Now look at this and look at this. You see that the time of flight is 2 times u all over g, and u all over g is simply the time to reach the maximum height. So we can say therefore that t will be equal to 2t, and that is what we are trying to prove. QED. The time of flight is equal to twice the time it takes to get to the maximum height. If you understood this, then solve this simple problem. What is the time to reach the maximum height by an object thrown up with a velocity of 5 meters per second? When you get the answer, please put it in the comment section and I'll be there waiting for you. Thank you for watching our video and see you in the next video.